Alrighty then. Alright, so this is chapter 1.5 for Calculus 2. So that means that I am going to go through kind of fast because you guys already got all these notes. Just refresher. Okay, investigate infinite limits. Find the vertical asymptotes of a graph. Investigate limits at infinity. Find the horizontal asymptotes of a graph. Find asymptotes of a graph of a rational function. There we go. As x approaches 0, the value of x, 1 over x squared, increases without bound. It increases without bound. So that means it goes on to? And? Thank you. Since when the value of 1 over x squared is not approaching a single number, okay, just to tell you, infinity is not a number, it's an idea, okay? You can't count to infinity, unless you're Chuck Norris.
Try me.
He counted to infinity twice. All right. Okay, the limit of, okay, not approaching a single number, the limit of f of x as x approaches 0 does not exist. Okay? So the limit doesn't exist. Okay? Does that make sense? The limit doesn't exist, but it is going somewhere, right? So now, okay, you guys ready? Warm up your arms. You ready? Okay. All right, you ready? All right, okay, you ready? Get ready, get ready. All right, so let's start off with parabola. Okay, all right, down. You ready? Okay, you ready? All right. X cubed. Okay, there we go. One up, one down, right? Okay. All right, okay. So now, okay, where, you ready? Okay, you ready? All right.
Yeah, I'm
okay.
ready.
Sine wave.
Oh, dude, like, yeah, I was like, go ahead.
All right, good try. Okay, so, yeah. Are you really waving right there? So are we doing the wave across? So yeah, so we're going to do the wave across the class, right? The sine wave. Yeah, don't do that. Okay, I was joking. Okay, I wasn't serious. Please stop. All right. Okay, so now, okay, let's get on topic here. So now, if a limit exists, what does it look like? Hands.
It's like,
There we go. Hands, right? Okay. Limit exists. Both of them go to the same point, right?
yeah.
Okay, very good. Now, they both go to the same point. So if the limit exists, it goes to that number, right? But now, if it's going up to infinity, like this one says right here, it's both going like this, right? Okay?
Yeah.
So everyone should be like this, right? And then when we're done, we go MCA, right? Okay.
Yeah.
All right. So, however, since it's increasing without bound, we describe the behavior of the function near 0 by writing the limit as x approaches 0 of 1 over x squared is equal to infinity. The limit doesn't exist, but it's going to infinity because infinity is an idea, not a number. Okay?
Yeah.
Yes, okay. Now, say that f of x equals 1 over x squared has an infinite limit, okay, as x approaches 0. In other words, a function of f has an infinite limit at c if f is defined everywhere in an open interval. Now, open interval. What is open interval? Come on, hands. Right? Okay. You should have parentheses right there, right? Parentheses. Okay. Not brackets. Parentheses. Brackets. So these are parentheses, right? Okay. Like I said, you got to get ready for this. Okay. All right. Okay. Containing c, except possibly at c, and f of x becomes unbounded. Unbounded, that means it goes to infinity and
Beyond.
thank you. All right. When x is sufficiently close to c. Does that make sense? I just basically summed up the whole thing for infinites.
Yeah, you don't need to do this anymore.
That is infinitely less complicated than what we did before.
Yeah.
Okay.
Class is over.
All right. Now, how about this one? Dun 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 dun.
0 from the
Dun
next.
dun. Now, since I'm pretty sure you guys don't know your ln rules, right, meow?
No.
Okay, you don't know your ln rules, right, meow? So, let's see. Use your handy dandy calculator.
That's what I'm on.
Okay, where am I going to enter this at?
What?
Where are you going to use Scratchpad or are you going to use the graph?
The graph.
Graph, thank you, graph. Because if you try the Scratchpad here, you might not like it. So, let's see.
Please define a variable for x.
Yep, that's what it says.
Nobody
trying to make it
defines
zero.
a variable.
That's why I said. All right, so let's see right here. Okay, so let's hit this up, and it said ln, right?
Yeah, sure.
ln x, right? Enter. And
Negative infinity.
let's see, what is it happening at? Okay, so now it said 0 from the right. Going to 0 from the right. What is happening here? So I'm going to go menu, trace to see what's happening. Start off at 0. It is undefined, right? Yes?
Yes, it is.
Okay, now, but I can keep going this way, can I?
Oh yeah.
Okay, I can keep going from this way. So coming in from the right-hand side, it is going to, right? But left-hand side, does left-hand side exist?
No.
No. Okay, the left hand doesn't exist, but we're not looking for that. Our problem is specific. It's 0 from the right-hand side. 0 from the right-hand side. So where is this going from the right-hand side? Down. Is it unbounded?
Yes.
Okay, so it just keeps going, right? So this is going to negative infinity.
That's a funny one.
Okay. All right, so let's take a look at. All right. Investigate. Now, this one right here, if I'm doing it from the right-hand side, can I just plug in 3 to see what I get?
Yeah.
Say no.
No.
Why can I not plug in 3?
Because it's going to be
Zero.
It would be undefined, it'd be 0 where?
And the denominator.
In the denominator, right?
Yeah.
In the denominator. So, yes, denominator. Okay, so, okay, let's see what we get. Let's go ahead and try and graph this here.
2x plus 1
It's beautiful. It's like this, and it's like this.
It's like abstract art.
Yeah.
It's non-representational.
It's modern art.
Yeah.
What did it say? It said 3x, right?
2x
Just
plus
swatch
1
of color.
Oh, 2x plus 1?
over x minus 3.
The center just
Is vanish.
Ah, crap. Ah. Over.
X minus
Okay. Bam. All right. So, on this one right here, okay, what is it asking for?
It's what?
From the right side.
Right side. So here's right side here. Okay. From the right hand side, where's it going?
To infinity.
Positive infinity. Now from the left side, where's it going?
Negative infinity.
Okay. So,
And 3 is undefined.
yep. And so right here, just from the right hand side of this, so the right side is going to give me a positive infinity. What about this other thing right here? Okay, limit as x approaches 1 from the left hand side of x squared over ln x. Now, can I just plug in 1? Say no.
No.
What is ln 1? 0. ln 1 is 0.
What is that?
they threw the x squared and then a weird wonky natural line.
Yeah.
That is.
All right, so what's happening at 1?
That's hard.
What's happening at 1 here?
Undefined.
Undefined. There is a asymptote, right?
Yeah.
Okay, so that means from the left-hand side, this is going to what? Negative infinity. So, what is another way I could test this besides just using my graph and looking at it? Tables, right? Building a tables. You're going to have to start doing that here soon too. Okay, building a table to see what it's going to. Okay, see what it's approaching. So you can see on the left-hand side, it's going down to negative infinity. So really, really big negative numbers. The right-hand side, it's going up to positive infinity, really big positive numbers, right? Okay. Find any vertical asymptotes of the graph. Now, vertical asymptotes are where? X-axis. Okay. Okay, there's a rule for it. How do I find the asymptotes?
Where the function is undefined. Or
Okay, so where what?
the function is undefined at a certain x value.
Okay, so now if I had a fraction, what would I do with that fraction? Set the bottom number to equal 0, right? Let's do that. Set the bottom number equals 0, and we end up with what? X equals 3. Okay, finding vertical asymptotes. X equals 3. Okay, that looks like I'm gonna have only 1 there, right?
Yes.
So let's see what handy dandy calculator says.
Yeah, it would be like 40. It's just all over the place.
Okay, so control divide. It said X over, right?
Yeah, x minus 3 squared.
Looks like only one asymptote there.
Volcano.
That's a wicked volcano.
Right? Okay.
Yes.
So, now, for this, does that make sense? Yes? No?
Yes.
Okay, good.
Of course it makes sense.
And here's a whole bunch of rules for it.
Makes sense.
Now, there's a reason why I actually gave you a handout with these rules already on it. Okay? All these things are stuff that you've already done before. We had this already when it's just x approaching c. Now, if I have a fraction, kind of like I previously did, I could find the limit as f of x, like this one right here. Right in here. So I could find the limit as the top approaches infinity, find the limit as the bottom approaches infinity as long as my bottom does not go to 0. Okay, and like this one right here, where f of x has to be greater than 0, what's going to happen here? If it is a square, what has to happen? There are so many mosquitoes in here right now. Ridiculous.
The inside can't be negative.
Okay, inside can't be negative, right? So if this is a fourth root, any even number root right here, any even number root cannot be negative. Okay. Find the limits at negative infinity. So, now, let's start this by tabling it. Okay. Start this by tabling it. So let's take a look. We're on negative infinity, right?
Yeah.
Okay, this is negative infinity. So if I'm going to consider it, it's going to keep going. So think about it like this. The bottom is how many pieces, right? Okay? Currently, 13 people in this classroom. I'm going to order one pizza. And we're going to share that. Okay? So it would be, okay? So we have the one pizza over 13 people. So how much do you get? 1/13, right? But what if I keep increasing the number of people in this class? What's going to happen to your slice of pizza?
Smaller.
Smaller and smaller. So now, think of that if I increase it to infinity.
What infinity?
I'm trying to feed the world with one Domino's medium pizza. So we could say, as it approaches infinity, that pizza just now turns into basically everyone gets 0, right?
Yeah.
What if you square that with
If you square that infinity, okay, then that means it goes up a lot quicker, right?
infinite less?
Yes,
Yeah.
infinite less. So with that many people, makes me just want to snap my fingers.
What the heck, dude?
I know, right? So mathematically, it's simple calculus.
Is that what it
There's a
is?
finite number of resources.
I was gonna say.
Yes, that's the quote from the movie, okay? Simple calculus. There's a finite number of resources.
I didn't know that's what I was watching the whole time.
Okay, anyway, all right. So yes, Thanos can do calculus. Anyway, all right, so let's see what it would be. So if I start off by putting that back, okay, I'm going to build a table and I'm going to start going. Let's start off with -1. What do we get?
Long way to negative 3.
You get 4.
I get 4, right? Yes? Okay. Let's start off with -2.
Good one.
Let's go -4. Okay, now it's getting smaller, right?
Oh, yeah.
Okay, and let's go -8. 1 what?
16.
Okay, notice how that slice of pizza is getting smaller and smaller and smaller. So it's going to be so small that everyone, only thing that's going to be left, you might be able to smell it. That's all that's going to be left. It's like when your sibling orders a pizza and he's all, oh yeah, I left you some, and all it is just like pizza bones or like the cheese stuck to the box. But you're still grateful for the cheesy box. Okay. All right. So what is this going to come out to be? 0. Okay. This one's going to come out. So if I go to negative infinity,
Kind of jump.
Yeah, I know.
and no matter the number,
Just
okay,
give me 8 seconds.
it's going to just be 0, right?
Yeah.
Okay. It's going to go to 0. Let's check the graph.
Oh wow, would you look at that? That's exactly what you get.
Okay, so now we have this here, 4 over x squared. Now let's start plugging in some numbers. So I'm going to trace, and let's start plugging in. So we had, was it -4? Okay, we had -8. We have -16. Okay, and you keep going. So let's go -256. Okay, so at this point right here, what is that scientific notation telling me?
There's 5 zeros.
Yeah.
There is 5 zeros in front of that 6, right? There's 5 zeros in front of that 6. So that means that it is so finitely small, I could say that this is going to go to 0, right? So I'm looking at the graph, how it goes, all the way out here goes to 0. Okay, so where are we at now? Take a look at the next one. So, this right here going to positive infinity. So, let's start by doing positive numbers on my table. Start with positive 1. What do we get? Okay, let's start with positive 4.
-5.
Okay, let's start with
600.
you want to do 100?
No, not 9.
Oh, listen, we're going to infinity. Just pick numbers that it's going to come out easy for you, right? You're building your own table out of this.
100.
25.
He said 25. All right.
Yeah, thank you.
Okay, so now you want what?
100.
You want 100?
-1.
625.
Was it?
625.
Okay.
Alright, Jimmy, that's all you.
Really? 625? Go ahead. Square root of 625 is 25.
Yeah.
So it's negative 10 over 25, which gives you negative 2/5, right? Okay. All right. So now let's try this one now. So as in going to positive infinity, what do you think's happening? It's going to yeah, it's going to -0. Sarcasm, just so you know. Okay, so. All right, so now this next one should be easy, and I'm going to show you why. I showed you those problems right here, okay, and I did that one in red for a reason. What would I do this one right here? Limit, okay, let's do limit. Let's break it up. X approaches infinity of 2 plus the limit as x approaches infinity of 3 over x.
Okay.
Now, with this exercise right here, what do we know this second part? The limit as x approaches infinity of 3 over x.
It's gonna be 0, yeah.
That one's going to be 0, right? Okay, so that one should be pretty easy. So as it goes to infinity, that becomes 0. What about the limit as x approaches infinity of 2? 2. So what do I do with my two limits? Add them. So what is the limit of this one going to be?
2.
Make sense?
Yeah.
Okay. All right. So I think that's the one I'm supposed to stop on. Yep. Okay. So I'm going to let you guys use the rest of this time. Don't forget, like, subscribe, and don't forget notifications, right? All right.